Okay, so this is the detector. Researchers use different types of detectors for gas chromatography. This one is kind of special because it allows us not only to detect the compounds, but also to identify compounds. And that's sometimes very important for us if we just don't know what kind of volatiles we have in our samples. For instance, when we look at volatiles that are emitted from Arabidopsis roots, we sometimes just don't know the compounds, and this is why we need that particular detector. So this is a mass spectrometer. I would love to open this to show you a little bit more, but it's running under vacuum and I can't break that vacuum, so we better leave it closed. But what I can tell you is when the molecules are entering the mass spectrometer, they're bombarded with electrons. And during that process, they're ionized. They're positively charged. They lose an electron, so a molecule is actually turned into a positively charged ion. But that's not enough to actually identify the compound. What also happens is through this bombardment with the electrons that the molecule falls apart. It falls apart into a group of so-called molecule fragments, which are also positively charged. So we have a group of ion fragments. And this group or mix of ion fragments is very specific for each volatile compound. It's like a fingerprint that is characteristic for a particular molecule. And I want to show you, since this detector is connected to the computer, I want to show you how this fingerprint looks like. Well, here we are at the computer and the monitor that actually is recording the compounds as they come from the mass spectrometer. And if we have a closer look at the chromatogram, so here you see in a close-up a gas chromatogram as it is developed by the mass spectrometer. Every chromatography or every detector in chromatography will give an output of so-called peaks, as you can see here. And these peaks represent the different compounds that are coming through the column and that are running through the detector. Now, the area underneath such a peak is proportional to the amount of compound that is detected. And so what does this peak actually represent in the case of the mass spectrometer? It does represent the entire group of molecular ion fragments I was just mentioning. So what I can do now is I can take my cursor and I can move cursor over a peak like this. And if we move further down here, what we see is the so-called mass spectrum. Now you might wonder, what is this all about? I see just a bunch of lines. Each line is representing a molecular fragment of the molecule. And the higher the line is, the more abundant is the fragment. So in this case here, we do have a monoterpene volatile. And this compound has a molecular weight of 136. If it's broken down, it will produce all of these ion fragments that we can see here. The number above each line represents the molecular weight of each ion. So for instance, this is a molecular fragment that has a molecular weight of 93. And this is the most abundant one because it's the most stable in the bunch of all of these ion fragments. But you see there's a particular pattern here. And this pattern is the fingerprint for this particular compound. Well, so how can I now figure out what kind of compound this is? Well, what the computer does for me, it compares this spectrum with thousands of spectra that are contained in a database or we call this a library, and it will try to match it with mass spectra that are in this database. This database has been established by researchers around the world who do gas chromatography, mass spectrometry, and they enter their mass spectra into the database. So now if I do a similarity search for this compound, a new window pops up, and this is my spectrum, and these are the ones that are suggested by the database. And the suggestions are all the same. It says this is pinene, beta-pinene, which is a very abundant compound in essential oils. So I was just taking an example here from volatiles of an essential oil mix. So you see several entries of pinene in this database, and if you see such a large number of the same suggestion, you can be pretty sure that this is the compound that you have identified. So we're now pretty much at the end of that little demonstration here, and I hope you got an overview and an idea how gas chromatography mass spectrometry works. And please don't hesitate, if you have further questions, to contact me, and hopefully I can provide some more information. There will be additional slides in terms of how the detector works, how the injector looks like, etc. So thank you very much.